This is Sangeeta Margaret, Assistant Professor, Department of Physics, St. Joseph College of Arts and Science. Um, Welcome to this video of X-ray diffraction and its methods. We have a small introduction on X-rays. So X-rays were discovered by Wilhelm Röntgen, and X-ray diffraction was discovered by Max von Laue in 1912. X-rays are the electromagnetic radiation whose wavelength ranges from 0.1 to 100 angstrom, and X-rays which are used for diffraction experiments having wavelengths of 0.5 to 1.8 angstrom. So X-ray diffraction based on the scattering of X-ray crystals. So during the during the scattering process, the electrons start oscillating. So the dipoles forms and the spherical waves is sent out. The scattered beam having wavelengths and energies that will not change, as in elastic scattering. When the X-rays interact with a solid material, the scattered beams causes diffractions, as you could see through the diagram which are represented here. So XRD principle, or here the different planes in a crystal gives different signals which are equal to positive interface of waves. Experimental diffraction methods having three types of methods. The one is Laue's method. Laue's method having two such methods. The one is transmission method, another one is back reflection methods. So in this video we are going to only talk about Laue's method. In another video we'll talk about a rotating crystal method and powder photograph method. So this is Laue's method. In this method, a single crystal is held constant, that is held stationary in the path of radiation of continuous wavelength, while theta is kept constant and the wavelength lambda is varied. So theta is the angle between the plane and the direction of the wave. And a photographic film receives the diffraction beams. So when we develop the film, we'll get the diffraction pattern that consists of series of spots. So Laue's method is able to indicate the symmetry of the crystal. Also, the Laue techniques has been extended to the study of imperfections resulting from crystal growth or deformation, because it is found that the Laue spots from perfect crystals are short, while those are from deformed crystals are elongated. We will just now talk about transmission method. So Laue's method is divided into two types. So the one is transmission method, the other one is back reflection method. So here the transmission method, the photographic film is placed behind the crystal to record beams which are transmitted through the crystal. When you pass a beam of X-ray from the X-ray tube to the crystal, as the crystal is fixed over here, so after passing through the crystal, the X-rays are diffracted, and which will be recorded on a photographic plate. So from that photographic plate, you can determine the atomic planes. from that diffraction pattern you could see the position of atoms, and this is a back reflection method. Here as you can see through the diagram, the photographic film is placed between the X-ray source and the crystal. So the beam which are diffracted in a backward direction, and also it is recorded. So it is used to determine the orientation of large single large crystals, um, and thank you.